neighbors that
All right, we're starting.
Because they just want to make it look bad. Because I don't get anything. But then one of them got me flowers. And
Do you have homework today or no?
no.
Okay, so let's finish chapter 14.
Are we going to
So-
finish chapter 14 by today? Or,
Yeah, that's the plan.
so is the exam Wednesday or next Wednesday?
The exam is the last test is the last day of class, and the final exam is
So would we go
whatever.
Thursday and Monday just to review?
No, we're gonna party.
Swear. Like, you just gonna cancel class and go
That's long.
Pull up. Did you mean turn up? I think that's what the kids say.
The 18, we have an exam.
Yes.
Yep. The last test is the 18th.
Are we gonna review for the final ever, or is it review for those?
No, we don't need a review. Everyone like knows their
But
stuff.
could we just take it
mean?
Monday and review on Wednesday?
No.
Yeah, we should do that.
No.
Do that
No.
for the final.
I want as many days as I can.
There's only 2 chapters, it'd be better to review for everything.
Okay, so last time I taught you guys how to look up the tables and stuff. Anyone need tables? I have a couple extra copies.
Oh, me please.
Mimi, I raised my hand first. It should be in the order. Wait. How to have it. Thank you. Okay.
That's it.
We'll share.
Bring it the next
You
one.
guys are supposed to be prepared.
A lot of expectations, you guys.
I don't remember.
I was like, there are only going to be like 1 or 2 people because they're all on point. They're all on top of this. Like,
It's final.
So you want to got to fight for this one?
You'll make them fight for it.
I got to fight for this one. I'm not even gonna look. I'm not even gonna look.
okay, so now we're going to generalize the normal distribution. Last time we learned how to look up stuff in the table and we felt really accomplished and stuff.
Yeah.
But that one is with the standard normal, right? That's the guy that has mean 0, standard deviation is 1. But what if you have some other mean or some other standard deviation? How do you deal with that?
Hold on a second.
Well,
The shaded area, what does that mean? That's what's covering? That's what this is
that's what the
covering?
number. So the shaded area tells you the area under the curve. It tells you the area that it's finding here.
I see.
So it says when you look up a z value here, that number that you see is the area of the shaded region.
Okay.
Right? So like I said, not everyone shades from negative infinity upwards. Some start at the half. So make sure the one you're looking at is one like this. It gives you the area under the curve to the left of whatever point you're looking at. Okay. So now we're going to generalize the normal distribution.
I realize.
Because not all the time will the mean be 0 and the standard deviation is 1, right? So we want to deal with other situations. Okay? So the table that we have has mean 0 and standard deviation 1, and it's very convenient. So the idea will be, in any other situation, you want to translate to this situation and find your answer, right? That's going to be the goal of today's lesson. So let's actually do that. Suppose x has PDF. This guy, this is the PDF for f. F of x is equal to 1 over sigma to the radical of 2 e to the minus x minus mu squared over 2 sigma squared. It's just a transformation, really. This takes the standard normal it shifts the mean to mu. Right? That's what x minus mu does. This shifts to whatever mu is. And makes inflection points curve at sigma and scales vertically so that the total area under the curve is still 1. Then x is said to be a normal random variable.
Wait, Jhevon, do you mean inflection points when you put points, whatever?
Yes, INF
Okay.
points, PTS. That was a shorthand. A normal random variable with mean mu and standard deviation sigma. So if you want some guy that's a symmetric bell curve, that is the mean is centered at mu and the standard deviation occurs at sigma, that's actually the function that you're going to plot. It'll look kind of like a bell curve, but it might be skinnier or flatter. It looks the same way, except your inflections will happen at a certain point. So that means the peak of your curve is going to happen at mu, right? Which may or may not be 0. And then these inflection points will happen at sigma, which is the standard deviation. Okay, so you're sort of shifting this guy. And we write, here's the notation for it, x equals n comma sigma. This is a notation you might see in other books. I'm not really going to describe it this way, but if you see this, you should know what it means. So for example, if I write x equals n 2, 3, this means it's a normal distribution with mean equals 2 and standard deviation equals 3, for example. So that's what it means. Now, here's a definition. So that's all well and good, but how do we use that? Well, we translate to the situation that we're already familiar with. For that, we're going to need an important definition, which some of you might have heard before. It's called the z-score. Okay, so suppose x is a normal random variable with mean mu and standard deviation sigma. And let x be a value x, the number of standard deviations from the mean x is from the number of standard deviations x is from the mean. Let me get my grammar here. X is from the mean is called the z-score. It is defined as, now this is a very, 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 very important equation. You have to have it memorized. Z equals x minus mu over sigma. Right? You find the distance that x is from the mean, you cut it up into sigma slices. That's finding how many sigmas you are away from the mean. This is the formula that gives you the z-score for the value x. Now, how you want to think about this is how it's going to help us. Think of Z as the standard normal Z value corresponding to X, right? So meaning that X could be some variable that has to do with the situation you're dealing with, but this will actually translate it to a value that you can look up on your table. Okay, so let's actually do some examples of actually finding z-scores, and then we're actually going to use it to answer some questions. Example. Suppose X is normal 5, 2. Find the z-score of X equals 2.5. Okay, how do you find the z-score?
2.5 minus 5 divided by 2.
Z equals X minus mu over sigma. Remember, this is the mu, that's the sigma. So this is going to be 2.5, which is your X value, minus the mu over sigma, which is 2.5 minus 2.5 over 2, which gives us what?
Negative 1.25 or negative 5 over 4.
That's it. Not so bad. Let's see.
For now. I mean, that was pretty straightforward. Are you going to put this in a problem?
Yeah, that was too easy. Let's make it harder. Theorem. Now let X be normal with mean mu, standard deviation sigma. Let ZA and ZB be the z-scores of X equals A and X equals B, respectively. Then here's the kicker. The probability that X is between A and B, and again, it doesn't matter if these are strict inequalities or not, is actually going to be equal to the probability that Z is between the corresponding z-scores. And so this is from the standard normal. So if I want to find the probability that X falls within a certain range, I can actually figure that out by looking at what its corresponding z-score falls within, what range it is on the standard normal distribution. Okay. So I basically use my Z to translate from X to the values on this table. And the probabilities will actually correspond between the corresponding z-scores of the original X values. Let's do an example. By the way, if something is normal distributed, they're I'm going to tell you. I'm going to say, hey, this is normally distributed. So it shouldn't be something that catches you by surprise. If you didn't know it was supposed to use a normal distribution, it's gonna say that, right? So the scores on that standardized test is normally distributed with mean 78 and standard deviation 12. The max score is 120. 8. What percentage of students scored higher than an 80 on the test? If failing means below 55, what percentage are expected to fail? What is the probability that a student scores between 75 and 90? If only the top 3% have a chance of getting into an Ivy League college. What's the minimum grade you need to have a shot at getting into an Ivy League? So here's something I told you is normally distributed. By the way, test scores are actually normally distributed usually. So if you look at like the statewide SAT scores, they will follow a normal distribution of some sort. So you have a test, you took statistics of all the test values that show up, you plot them, and they appear to be a symmetric bell curve. And you use Excel, you end up with finding that the mean is going to be around 78, the standard deviation is around 12. The max score on this exam is 120. And now we're going to answer these, given that we know it's normally distributed. So we know what distribution we're going to be looking at. Okay, so what we're going to do here is I'm going to let x equals the possible test scores. Okay, let's start with A. What is A asking about?
What percentage age of students scored higher than 80 on this test?
Okay. Describe that in math language, what they're asking for. Percentage is just chances, right? Which means
So
you
if
can
there's
write a
100
probability.
students,
So it's the probability of
80 out of 100.
what?
X is
Right, so X is
greater.
greater than 80. Right? So when you read that, this is the first thing you want to do. When you read a word problem, you immediately write down in math what is it you're looking for. That will kind of give you something to aim for, right? So you have to translate it, right? So we want the percentage of students who will score higher than an 80. So you want to get greater than an 80. So if I let X be the test scores, I want X to be greater than 80. Okay, so now how do I continue? I know it's normally distributed, which means I want to use this table, which means I'm going to need to do what?
1 minus the root of less than 80. And then,
Not necessarily. That's something I want to do first. If I want to use this table, what do I need?
z-score.
I need the z values, because this table won't tell me about z values. Here I have x values, so I need to translate it. So the first thing I'm going to do is I'm going to find the z-score. First, find z-score. So when you have a normally distributed thing, the first thing you're going to want to do is find the corresponding z values to the x values that you're looking for. First, find the z-score. So if I find the z-score of 80, what's that going to look like?
minus 78 over 12.
Right? Remember, this is x minus mu over sigma. They told me the mu was 78, the sigma is 12, so I'm going to use the x value minus mu over sigma. And what is this? 0.166, so it's around 0.17 to 2 decimal places. All right, so when you're doing this stuff, you only look up 2 decimal places because that's how far the table here goes.
Okay.
So you'll just do 2 decimal places. So in other words, the probability that x is greater than 80 is actually exactly the same as the probability that z is greater than 0.17. And these things we were looking up last time. So how do you find the probability that z is greater than 0.17? So basically I have this guy. There's a 0.17 here, and I want the area over here.
You want what area?
Greater than means I want to be on the right side. So what do we look up?
1 minus the root of z or less than 1%.
Right, so we look up the table value for 0.17, which is, what's that? 0.5675, right? Which is 0.5675. Now what does that represent?
The other side.
The other side, the area to the left. Remember, our table will always give us the area to the left. So I know the area over here is 0.5675, which means the probability that z is greater than 0.17 is going to be 1 minus that guy. 0.5675, which is 0.4325. So there's a 43.25%.
So we'll call higher than 80.
That someone will score higher than an 80. So the idea is, knowing that it's normally distributed, I can translate to z-scores, and my z-scores allow me to look up probabilities from this table. Once I have the probabilities, I can answer whatever question they ask me.
Okay.
So that's the probability that someone will score higher than an 80. Part B asks for what?
The failing. The probability of failing.
So we want to know what is the probability, B, as for the probability of fail. But what does fail mean?
I mean, X is less than.
X is less than a 55. That's what means fail. So what do I do here?
Turn up.
Did you say turtle?
Find the z-score. So I find the z-score of 55, which is going to be, gives us to 2 decimal places, 1.92, which means I'm over here at minus 1.92, and I actually want the area on the left, because I want to be less than.
So it's negative 1?
So the probability of fail is going to be just whatever value I get by looking at this guy in the table.
0.0274.
0.0274. So what did it ask? What percentage of students are expected to fail? So this means 2.7% are expected to fail, which means a horrible test. Should be at least 30.
Jesus. That's perfect.
Question, how do you know the side they want again? Like, for,
By figuring this out.
oh, okay, so if it's less and then they want.
If you're less, you want the left side. If it's more, you want the right side.
But over there, then we had the opposite.
We want it to be greater than 80.
Okay.
Because it's easy. You said that the max score is 120. What variable is that?
Just I mean, technically you could do it as an upper bound, but this, remember, this actually goes off to infinity. So stopping at your 120 will be super close to 0, but it won't make a difference. Part C. What is this probability that a student scores between 75 and 90? What do I want here? Probability that?
75 is less than X, which is less than 90.
Right, I want to know what's probably that X is between 75 and 90. So what am I going to do?
Find the z-score.
Find the z-scores for each. Z of 75 is 75 minus 78 over 12. And Z of 90 is going to be 90 minus 78 over 12. This one is going to be
75 divided by 12 equals to negative 0.25.
0.25
And 1.
1.
Yep.
So in other words, the probability that my X is between 75 and 90 is exactly the same as the probability that my Z is between minus 0.25 and 1. And how do I find that probability? Right, so this is basically, that's my graph. I am between minus 0.25 and 1. So I want the area here.
So you can subtract 1 when it says?
Yeah.
Can you subtract them?
Subtract 1.
Subtract 1 from negative 0.25, which gets you.
First you have to find the number that corresponds to it.
Alright.
Right, so you find the area under 1 minus the area under minus 0.25, right? Because that you take this area and subtract that area, you get the area in between.
So for negative 0.25, you want it 0.4013 for negative.
This one?
Yeah.
0.4013.
Yeah.
And for 1?
0.8413.
0.8413. So that would give us what?
Like 40%.
0.4 what? Just 0.44? Oh, it's 1 3 at the end. Yeah. So this is, did it ask for a percentage?
No.
What's the probability? That's the probability.
44%.
There's a 44% chance that you will score between a 75 and a 90. Okay, last one. The top 3% have a shot at getting into the Ivy League school. What's the minimum score you need to get into an Ivy League school?
You have to go backwards. Do you have to find out the area that covers 3%?
So what would that look like? This is D. What are they actually asking here?
300. No.
Where would the 0.03 be?
On the positive side, next to the 0.
So there's something over here, and 0.03 is what? Is it the number here?
Well, wouldn't it be on the negative side?
Huh?
Should be 1.88.
What's that 0.03 though? What's that 3%? Where does that go?
It's... Oh, okay. It's right around here. To negative 1.8.
That 3%, what is it referring to? The 3%.
It's referring to not the z-score.
What's your question?
It's referring to not the z-score? Is that what you said?
This number two.
They're both z-scores, look.
3% refers to what?
Are these the full z-score?
The numbers between negative
Oh.
1.88 and 1.8.
What does the 3% refer to?
The amount of students that are going to get into Ivy Leagues.
Yes.
Okay, the top 3%. Yeah, in this math problem, what is it? Is it a z-score? Is it an x value? Is it, what is it?
It's a z-score.
3%?
No, 0.03.
It's a probability, right. So what does a probability translate to?
You know,
On this graph, where would we see a probability? Probability is equivalent to what on our graph?
area.
An area, right? So that 0.3 is the area over here, right? It's the first thing you're going to figure out. What is this number that they're telling me? What is it? It's a percentage, which means it's a probability, which means it's an area, right? So they just told me an area, right? Which means I don't know what z value gives that to me. That's an unknown at this moment. But could I find it?
Yes.
Yes, you can.
Because that would mean the area over here would be what?
0.97.
0.97. So all I need to do is figure out when is the area 0.97. So how do I figure out when the area is 0.97? I go to my table. And where would I look in my table? For 0.97 over here? Like point. Right. Remember, the areas are in the middle of your table. That's what those guys give you, right? Remember, in your table, the area is over here. And the z-score is over here.
Yeah,
So you need to figure out, am I looking for a z value or an area? In this case, we're told an area, which means I have to look inside the table. I'm going to look inside the table for 0.97, and I'm going to backtrack to figure out what z value gives me that 0.97. Once I find the z value, I can actually find the x value.
Alright, so we got 1.88 and 1.89.
So 0.97, let's look where that is.
There's
Why couldn't you look up-
9699.
You have 0.9699 and 0.9706. It's a lot closer to 9699 than it is to 0.9706. So I'll actually just probably take the one for 9699.
Because you said, maybe
Because that the mean goes toward the center, but it won't be exactly toward the center.
So why couldn't you find the area of point
Right, if I'm at 0.9699 and I'm at 0.97, what is this? 06? How many units? The 0.97 will actually be closer to that one, right? Yeah, so if I take the average of these two, I'm going to get the number over here. I mean, technically I could do a linear interpolation, but I don't think you need to get that crazy. I'd just use this one as the approximation. It's a lot closer. If it was more like towards the center, I'd probably average them. But for now, I'll just take this value. So I'd look up that value, and in the table, if I go across to the left, I have 1.8, and then if I look up, I have 0.08, which means here, my Z value is actually 1.88. It's a little larger, but it's not going to be a big deal.
So now you need to solve for x?
Right, because I want to know what score I need to get on the table, right? I know what the Z value of the score is. So how do I get what the score is that I need to get?
You can multiply times 12 and divide by 78. No?
Now we know that Z is equal to x minus mu over sigma.
Solve for x.
So you solve for x. So this is 1.88 is equal to the x value minus 78 divided by the sigma. So you're going to get 1.88 times 12 plus 78 equals x. So what is that? 100.56. So the max score is 120, but if you score like 100.5, 101 or so, you actually have a shot at getting into an Ivy League. According to this data here, which I just made up. There's no test where the failure rate is like 2%. Come on.
That's like an 80-30.
It is for liberal arts majors.
So that's the score you need, min score needed for Ivy League school. Any questions on that last example?
Yes.
What? Yes.
Why were you figuring out point 97 instead of point 03?
Well, 0.03 is on the right side. Our table tells us things on the left side.
So then you do
So looking up something in terms of the right side is useless.
Okay.
Right? If I'm going to look at the values inside the table are the values on the left side. So if I'm given the right side, I first figure out the left side. The left side is what I'd look up in here, because these are all the left sides. So I can't look up the 0.3. If I just looked up a 0.3, that'll be over here, which is really like, everyone can get into an Ivy League. Any other questions? Right, the values in our table tell us the values, the area to the left. So if I know the things on the right, which is the greater than, I have to switch to the left to actually look it up. Here's something cool. We can use the normal distribution to approximate a binomial distribution. Why would we even want to do that? Binomial is so easy. Well, consider the case where in the binomial, you have tons of calculations to do. You know, like your n is really large, like you're repeating something 1,000 times, and you want, what's the probability that it's somewhere between 250 and 795 successes, right? You don't want to do like hundreds of calculations. You can actually use a normal distribution to approximate it, because with a normal, no matter what your interval is, you only have to look up two values, the right endpoint and the left endpoint. For a binomial, you have to go step by step and calculate each one. Turns out, we can use one to approximate the other. The normal can be an approximation for the binomial when your n is very large. Is this a theorem or is it just notes? It's actually a theorem. And it gives you the values, which I don't remember. But suppose x is a binomial where n is bigger than 30, so it has to be large for this to really work. Mu is greater than 5, and nq is greater than 5. Whenever I ask you to do this, these situations will automatically be fulfilled, so don't really worry about it. By the way, recall, if you're in binomial, what is your mean and standard deviation? Mean equals?
Mean is equal to all the x's.
Yeah.
N times p, and sigma is?
NP.
Radical of npt. So if you have a binomial, we know what the mean and standard deviation are, right? I'm going to actually use those values in my normal distribution, but we need to figure them out, right? As long as your n is large and your mean is also relatively large, bigger than 5, you can actually use a normal. So x is this random, blah, blah, blah. Then, here's the kicker. Let me do the corresponding blah, blah, blah.
Jhevon, is that an S or a 5? And
This is a 5.
Oh, okay.
Then, the probability that x is between a and b, right now this is a binomial probability, will be equal to, will be approximately equal to, right? When these conditions are fulfilled, it will be very close to the actual answer. The probability of z is in between these two values. A little more space here. Basically, I'm going to calculate the z-scores, but I'm going to do one little tweak on it. The lower bound is going to be a minus mu over sigma. The difference is, my a, I'm going to subtract 0.5 from it. And I have b minus mu over sigma, so it's almost like a z-score, but to the b, I'm going to add 0.5 to it. This whole thing where I add and subtract 0.5, this is a 0.5 by the way. It's called a continuity correction. I can't do a direct translation because the binomial, as you may recall, is discrete. While the normal is actually continuous. Basically, they're not the same thing. The binomial is going to have gaps while the normal won't, right? So if you're plotting a binomial versus a normal, right? The probability graph for this guy would be like a histogram. Right? The probability graph for this guy is going to be like that. So if I want to find an area in the middle, I'm just shading these guys. Well, if I want to find the area in the middle, I'm shading everything here. The idea is there are gaps here and there are none here. So things are kind of weird. You can use some really complicated math to prove that if you add a half and subtract a half, it actually makes this one more closely fits that one. You don't really need to know why it works. This is just how it works. It's actually beyond our scope. Right? So you need a continuity correction note. You only need the continuity correction when using a normal to approximate a binomial. So in other words, the situation we find ourselves in is the following. In the beginning, it's a binomial random variable. It has all the characteristics of a binomial. However, n is really large and there are just too many calculations to make it practical for me to compute. So what I can do is I can use a normal distribution to approximate it, and this is how I will approximate it. I kind of do the z-score, but I fudge things by a half in each direction. And that kind of, it gets rid of the messing up that the gaps cause in one versus the other. Right? So that means you're given a binomial, you want to use a normal to approximate it. By the way, how do you know if something is a binomial?
Three
Follow 3
sides.
steps.
You can repeat the experiment. There's two viable
You're
results,
repeating an
success and
experiment,
failure.
there are only
and
two
they're-
possible outcomes,
And they're independent of each other.
and they're independent, right? So once you read a word problem and those three things are fulfilled, you're dealing with a binomial. However, it might not be practical to view it as a binomial because there are just way too many calculations, hundreds, tens, thousands. Okay, so what you can do is you can sort of translate it, right? And use a normal. So let's actually do that. Example. The probability of was probably that at least one will get it. Oh, asterisk that formula, super important. You have to memorize it. The one I just said. Oh man, no, I can't remember it. At least one will get an A. B. What is the probability that between 50 and 52 will get an A. C. What's the probability that exactly 100 will get A's? Estimate the probability that at least 100 will get an ace. Okay, so that's the situation. The probability of getting an A in a certain bio class is 0.15. I'm freezing. Suppose there are 200 students in the class. What is the probability that at least one student will get an A? Please let him know. I'm registered for that guy's class this summer. These are actual statistics. I don't know if these are actual. Forget it. I'm not going to say anything. It's probably much lower than that, actually. Okay, let's start with A. All right, let's set this up. Like, what do we do? What is the first thing we do?
P is equal to 0.15.
Why?
Is it binomial? So we do P.
How do you know it's binomial? Huh?
You told us. It was the binomial.
Yeah, well, if it's on a final, how would you know it's a binomial?
Well, there's a pass or fail.
Yeah.
It's a repeated experiment,
And it's independent.
and it's dependent. One grade is dependent.
It's not pass or fail. You think of it as A and not A, like an A minus, not a fail.
Well, have we spoken
It's
to
like, my life is over. Got a stupid A minus. Never get into med school. My parents are gonna kick me out. Girlfriend's gonna dump me. I'm gonna get hit by a bus. Like, everything's gonna go wrong. I'm just going to hell. No, it's not like pass. It's like A or not A. It's not. Right?
be A or not to be?
So you're repeating an experiment. You're pretty much checking the grades of 200 students, and you're checking if they got an A or they didn't. Right? So you're repeating something a certain number of times. Your two possible outcomes: either they got the A or they didn't, and each is independent. Right? Assuming no one cheats off anyone else. Okay. So now that is a binomial. So it's a binomial random variable. So now let's actually define our variable. Let x be. What am I going to want x to measure? What do I care about? The number of people who get A's. I know my N is, my P is, my Q is, N is
N is a number.
200, P is
0.15.
0.15. That's the probability of getting an A, which is what I'm counting. So this is going to be 0.85, 1 minus P. Okay, so I know it's binomial because it has all three characteristics of a binomial. So now in part A, what is part A asking me for? The probability that
K is what? X is equal to 50. X is between 50 and 50.
you're looking at part B. A starts here.
Then you get at least one.
So what does that look like? Probability of X greater than or equal to 1. Alright, how would I do that?
1 minus probability of x equals
1 minus probability of X equals 0, right? Which is 1 minus probability of X is less than 1, which only has one situation. 1 minus probability that X is 0. So what's the probability that X is 0?
So 0 that n choose R.
Right? So it's 200, choose 0.
P is
P to the
with 0.
0.
Q to
Q to the 200 minus 0.
0.
Right? So this is 1, that's 1. So it pretty much means everyone's fails. So you have 0.88 to the 200th power. That's going to be what? That's like super small.
7.65 times 10 to the negative 15.
That's what this is?
So
That's-
1 minus
that's what-
that, sorry.
Yeah, so 1 minus, like, it's going to be pretty much 1.
Just 1,
right?
yeah, but, yeah.
Oh, right.
Right, so yeah, we're pretty much certain at least one person's going to get an A. Come on, there are 200 students, there's a 50% chance. Yeah, we're pretty sure.
I got it.
It's not exactly 1, but it's going to be like 0.99999, a bunch of 99999.
Yeah.
Right. So it's pretty much certain that someone's going to get an A. Okay, so let's not jump out the window just yet.
Wait, how did you come to the conclusion that it's 1 minus the probability of x less than 1?
Complement. I use the complement here. Right? Because remember, it's binomial, so at least 1 means 1 or 2 or 3 or 4, all the way up to 200. I'm not going to want to do that, so I look at the opposite.
Okay.
Right? Which means 0. Okay, part B. What is the probability that between 50 and 52 we'll get an A? So this means I want the probability that x is between 50 and 52. Which basically means probability of 50 plus probability of 51 plus probability of 52 plus probability of 50 people getting an A. 200,
Choose 50.
choose 50,
So 0.50.
P to the
50.
50, Q to the
150.
150 plus 200, choose 51, P to the 51, Q to the 149, plus 200, choose 52, P to the 52, Q to the 148, and what's all that? What?
1.33 e to the negative 4.
For all of them? You added all of them together? 1.33 times 10 to the minus 4?
Yeah.
Yeah, so that's basically 0.123133. Right? So it's a very small chance that only between 50 and 52 people will get it in. It's less than 1%. It's about 1/10 of 1%. Okay, what is part C asking me for?
What is the probability that 100 will get it?
Probability that
Exactly.
What exactly 100?
x equals 100, exactly. Which means this is 200, choose 100, p to the 100, q to the 100. So I have 100 getting A's and 100 not getting A's, and that's roughly
3.22 times 10 to the negative
3.22 times 10 to the
31. Negative
21 or 31?
31.
30.
31, which is pretty much nothing.
Yeah, okay.
Right, that's like 0.0 with 31 zeros and then a 3. It's like it's pretty much nothing. Right? The chance of exactly one person getting an A in this, exactly 100 getting an A is pretty much nothing. Okay. Now, what about D?
The probability that P is greater than 100.
X is
Greater.
0 equal to 100.
greater than or equal to 100. Now, how do we do that one?
Now we use the normal distribution.
Now use the normal. Why would you think of doing that? Well,
Because it's a lot of work.
you're like, well, if I compute it directly, I'd have to find probably 100, 101, 102, blah, blah, all the way up to 200. Oh, this is a complement. Okay, then I'm going to need 0, 1, 2, 3, all the way up to 99. Like, either way, you're kind of screwed. So you're like, okay, not looking good either way. So I wouldn't want to use a binomial here. And this kind of hints to you, which is, it's very typical. You'll see these in finals all the time. they wouldn't say find the probability, they'll say estimate the probability. They're kind of giving you a clue that computing it directly is not going to work out in your favor. So it's going to say estimate. Sometimes they might say use a normal distribution to estimate it, but they usually don't. They might say estimate or approximate, or they'll specifically say use a normal distribution to do this. So when you're going through the past finals and you realize that something's actually a binomial, but they're asking you to estimate it, it means like they want you to use a normal because it's going to be a pain. Okay. So the idea is that's actually not something I want to spend my evening doing. So how do we actually continue?
From the mean, from the standard deviation.
Right. We'll need those guys to compute the corresponding z-scores. So the mean would be
NP.
n times p. So that's going to be 200 times 0.15, which is
80.
it's 30.
Yeah.
And my sigma is going to be the radical of npq, which is
5105.
5.105?
No, 05.
5.05. Okay, so now I know my mean and standard deviation for this scenario, which means my p of x is greater than or equal to 100 is going to be approximately equal to, all right, let's see who's going to get confused now.
Oh.
What do you guys think I should write? I'll start you off.
Okay.
100 plus 0.5.
Nope.
100 minus 0.5.
It was like, well, it's one, two. It's not a plus. It's not a plus. Sorry. Why is it minus?
Because it wasn't plus.
Yeah, that's not going to work well for you on a test. You don't just like flip a coin. If you flip a coin, it probably half. Oh my god, and then you have to compute a binomial on your thing. Like, what's the probability that I guess this correct? Oh wow. I make it into med school. My life is not over. My parents don't keep me out of my girlfriend doesn't dump me. Why do I take a minus? It's 100 minus 0.5 minus the mu, which is 30, divided by the sigma, which is 5.05.
You are a mess.
Why was it a minus? What was that formula we wrote down?
A minus 0.5 minus mu divided by sigma.
So it says my x is like this, right? Then this is approximately equal to a minus 0.5 minus mu over sigma, and b plus 0.5 minus mu over sigma. Right? Notice that here you subtract a half from which bound, the upper or lower bound? From the lower bound. And you add a half to the upper bound. So it doesn't matter that if I write it on the right or the left. What you should realize is that 100 is a lower bound for x. It's below the x, right? The 100 actually corresponds to the a, not the b, right? And so because it's a lower bound, I subtract a half. Right? So that's why I'm going to subtract. So let's actually do that. So this means the probability that x is greater than or equal to 100 is approximately the probability that z is greater than or equal to what? What's this number? 99.5 minus a 30 divided by 5.05 is?
13.76.
13.76? Okay. So what is that? Now we go to our table and we want to try to find 13.76. And we freak out because it's not there. Oh my god, I'm gonna fail. I'm not gonna get into med school. My parents are gonna kick me out of the house.
Is this funny to you, Jhevon? Because that's me on a weekly basis.
I know, that's why I'm making fun of it, because I know that's you guys.
Or was that you as an undergrad?
No, I did not worry about it.
I'm gonna be.
I was like, please get degrees, man, just chilling. Oh, you guys going to a party tonight? That was me. I was turning up all the time. So, basically what that means is, so what we're gonna look for is like a 13.76, right? And I pretty much want to know what is the area over here, right? Now, if you look at this table, the highest it goes up to is like 3.4 or 3.5. And some tables will actually take you up to 4. But I know like at 3.5 or 3.4, what is the area that's covered over here?
1 minus that.
What?
Okay.
It's like 0.99999, like 0.998, right? This is already almost 1. Right?
0.002.
And now we're going way over there, like 10 more units down, right? So pretty much like over here, the area is pretty much 1, right? Which means over here, the area is pretty much
0.
0. Probably is pretty much 0. Like, there's no chance of at least 100 people getting an A in this class.
So the thing is, we find what that equals using the normal distribution, and
Yeah.
then we.
Now, if this was a nice number, like it's less than 3.4, you literally just look it up and you take 1 minus the number.
Where did 3.4 come from?
Oh,
That's
3.4 is like the
the
largest value on this table.
The same.
Oh.
Well, 3.4 is 6.1. Wait, what? Doesn't make sense.
3.4 is the largest? Why do we get that the largest?
I want to get up to 13. My table only goes up to 3.4.
Oh, I see.
So I'm kind of teaching you to deal with a situation where it's not on the table. What do? Basically, if you're in one of the extremes, it means you're going to be either 0 or 1. Right? So if you're below like minus 3.4, to be less than that, it's pretty much 0. If you're above 3.4, to be greater than that, it's pretty much 0.
Yay.
Right? Because like the vast majority, 99.99% of things will fall between minus 3.4 and 3.4. So the guys on the edges, there's pretty much a 0 chance of you being here.
Jhevon, so we have like 10 minutes left. Can we go over the exam?
What is it?
The last one that we just had.
Oh, that's.
You guys want to go over the exam?
Yeah, the last page.
Pretty much the last thing.
Oh, what was on the last page?
The probability.
Oh, well, that was what we did today. You guys can do that.
Yeah, but why was it on the exam then? You couldn't do it?
It's a bonus.
No, it's not. Not really.
You're talking about problem. You're talking about problem 5.
Yeah.
5, not about.
B and E. It's not. And then the bonus.
No, you guys should try the bonus now because I pretty much it's like talking about normal distribution and stuff.
So we're supposed to try to know chat about that.
Okay, I have like I have version 8,
Where's your pen?
problem 5. Yeah. So what do we know that the probability of J is equal to what?
0.13.
0.18. I have version 8. You might have a different version.
I don't.
Probability of
Here
R
are.
in this is 0.1.
Okay.
Wait, yeah, 0.1. And then you are told that the probability that you got A's in both is 19%. Which means probability of J and R is 0.19. Okay, now I ask the question, are J and R independent?
Yes. No. I put yes, I got it wrong, so no.
Are J and R independent? How do you check?
Isn't it J slash R?
Well, if you take the probability of J
And R.
times the probability of R,
And it should equal-
you get 0.018. Whereas if you take the probability of J and R, you get 0.19, which is not the same. Right? Remember, independent means the probability of and is the product of the probabilities. So the answer is no, it's not independent.
That's the key. Okay.
Are J and R mutually exclusive?
No,
It's no, but why?
because you can have an A in both classes.
Because if you did the probability of A, J, and R, we didn't know that's 0.19, but in particular, that's not 0, right? Mutually exclusive means the probability of AND is 0. Here, the probability of AND is not 0. So no, not mutually exclusive. What is the probability that a student received an A in Jhevon's class or Raymond's class? So that's asking for a probability of J or R.
Is equal to
The
P of J
probability of J plus the probability of R.
minus P of J and R.
Yeah.
Minus probability of J and R.
Yeah.
0.18 plus 0.1 minus 0.19.
Is that 0?
No, it's not for me. Not for B.
What?
Not for version 3B. I don't know.
Yeah, so I don't know what 3B, the answers are different.
Well, for B is 0.16.
0.09.
Yeah, for B it would be 0.09.
No, for A.
For A.
On version B?
0.18
Yeah, version
plus
B would
0.19
point-
equal to-
Wait, what are we talking about?
It's
What is
not
0.09?
equal to 0. That is not equal to 0. Minus 0.19. It's 0.09.
I have 0.09 for C. I have
It's
0.09.
0.09 there.
Yeah.
What do we have? Oh, it's point 1.
0.09.
I thought it's 0.01. Okay, 0.09.
And then
That was it. So that's it. That's the answer. D.
Yes, please.
It's 20 of the students who approve.
That's where I got lost.
20 students in the group are randomly selected. Was probably at least one got an A in Jhevon's class or Raymond's class. Okay. So what is that?
None got A. Is it?
What does that mean? Or at least one. At least one A in G or R means 1 minus
the probability of A.
probability of
No.
none getting A in either. So this is 1 minus, what's probably that no one got an A? So this is probably of getting A in one or the other. So the probability of not getting A in one or the other is just going to be 1 minus that guy. But then that has to happen 20 times. So you multiply.
So you get no points if you put 20 in it.
Come again?
If you don't put the 20, you took out all points.
Yeah, that's actually pretty
I
cool.
tried. That's not.
What is the probability that all 20 got A's? Right, so that's just going to be 0.1, 0.09 to the 20.
I have a question.
Yeah.
Doesn't matter if 2 decimal places or 3 decimal places. I mean the solution.
I think it was 2 decimal places in there.
You didn't mention that.
Yo no sé.
It was in the instructions. If you wrote like this, that would be fine.
E is that one.
Yeah, all 20. Right, this means getting an A in either one. That happens 20 times in a row.
You can give me a point for writing the correct answer with other 20.
That's what I'm saying. Evil.
20 is
How do
fine.
you?
There are 20 people. Like without the 20, that's just the answer for like one person.
Yeah, but then you have to do the P minus the 1. Like, what if you roll P? You're evil. That's what I'm
Thank you.
That means we finished the syllabus. Yeah!
saying. So are we reviewing on Wednesday and Monday?
No,
At least
I'm just.
and that's the culture.
I'm not planning on showing up. I'm just coming on Wednesday to give you guys a test.
Are you
So
gonna be
no
serious?
class-
I can't tell.
No class Wednesday and Monday, right?
Look, we finished everything.
So we're done.
So wait,
So we're gonna
if I
review.
don't come Wednesday, it's like,
No, I'm gonna like deduct 50 points.
But how do we?
No, but
So are we gonna review? Because
yeah, ain't no class.
So what do you guys want to do? You guys want to review or you guys want to go on to chapter 15?
Is 15 on the final? Is 15 gonna help me in life?
What?
Is 15 on the final?
If we go over to that,
So then why would I want to learn it?
Because it might help you in life.
No, it's not, Jhevon.
Aren't you guys doing research?
Jhevon, no, I'm not. Jhevon, do you think my life is that together?
regardless. So the math.
I wouldn't mind if we go over this
Okay. So yeah, I guess from now on we can review, do all the homework. So chapter 14 homework is due next, due on Wednesday. And I guess we can start on final reviews. Print out the finals, bring them to class. Yes. Okay. I'll see you guys on Wednesday.